All right, so good morning, everyone, and welcome to our session on Apache Spark. My name is Suraj, and I'll be your instructor at OLC. So let's talk about this program. So we have a 40 plus hours of program on Apache Spark, and what we are doing is we are offering a 10 hours of fundamental program to everybody so that you are good enough to understand and take it forward on your own. Okay. Now, let me tell you how this course is actually designed. So Apache Spark is basically a big data processing framework, and we all know that we can either use Java, Scala, Python, or R to use this Apache Spark, right? But then we would basically focusing on Scala version, right? So you can use Java, Python, R, and Scala, and we would basically be focusing on Scala. Okay, we'll be basically focusing on Scala to write our program on Apache Spark. Now, a lot of companies are also using Python. Okay, few companies are also using Java, and few companies are also using R. So it's basically a choice. It's basically a choice by the team. It's basically the choice by the people. Okay. Now there is no such rule that you have to use this, right? But then I basically personally prefer Scala. The reason is because I've been working on Spark since last 5 years at least, and almost in all my assignment I have used only Scala. The reason is because Scala is short, quick, and crisp. Okay, and one of the reason why I would basically personally recommend everybody to learn Scala for Spark is because Apache Spark is built on Scala, right? And what is a Scala? Scala is a JVM based language, is not it? And let me tell you, you like it or not, but then most of the industry, they basically build the product on JVM based framework. Okay, most of the time. Now these days Pythons are also picking up really good, right? But then it's all because of machine learning. But then if we talk about the development, if we talk about the software engineering, if we talk about big data development and all, we still prefer using Java and Scala as our preferred language most of the time. Okay, now as I said, it's a choice of the people, it's a choice of the company. Simple. Okay, now let us understand why Scala, why Java, right? So as you know, all the big data products are majorly licensed to Apache Software Foundation, right? So we have Apache Software Foundation, and under this you will see a lot of big data tools. Almost every big data tools are actually a product of Apache Software Foundations these days, right? Apache Hadoop, Apache Spark, Apache Hive, Apache Pig, which is gone now, Apache Scoop, Apache this, Apache that, and whatnot, right? So most of the products are basically Apache software products these days, and trust me, most of the Apache software products are all Java based, right? And the reason why they are Java based is because Java has already proved its worth, right? All right, so we understood that Apache Spark is basically a product of Apache Software Foundation, and mostly they are written in Scala, and that's the reason the recommended language to be used would be Scala. Okay, but as I said, it's a pure choice. There are companies using Java, there are companies using Python, and so on. Okay, now let us talk about what is a Spark, right? What is a Spark and why it is so much popular these days in the market, right? So it's been popular in the market since last 5 years. Why it is so popular even today? Okay, so a Spark is basically a big data processing framework, right? A Spark is basically a big data processing framework that can help you to process the data at scale, and the scale can go anywhere till petabytes, right? So I've worked with a lot of companies on data engineering projects. My last assignment was with Apple, wherein we were using completely Spark on Scala. Okay, but then I don't say that there were not teams who are not using Pythons. There were teams who are using PySpark as well, right? But then we were completely working on Scala Spark because we wanted to build some robust product. And as you know, Java has already proved itself over the period of 20 years, right? Okay, so Apache Spark is basically a big data processing framework. Okay, and they are now widely used across the industry. The main reason is because it is in memory. Okay, so here comes a big question to all of us that, okay, Apache Spark has come to the market, but what about Hadoop MapReduce? We know that there are some concept like Hadoop MapReduce, So do you mean that Apache Spark is a replacement of it? Let us try to understand that. Okay, so let's talk about the next point, that is MapReduce and Spark. Right now, this is a very common question people ask day in day out, that is MapReduce outdated? Is a MapReduce replacement of Spark? Let us try to understand this. Okay, now see, usually when we started this big data, right, so earlier everybody was using just MapReduce because there were no choice, there were no options, right? And as we know, MapReduce always uses a disk to perform input and output operations, right? For example, suppose you are given a data, you have a data, let's say a raw data, and say this data is of 10 GB. Now if this data is of 10 GB, then earlier we used to write a MapReduce job, right? And this 10 GB of data would basically reside where? In your SDFS. That's not it. In SDFS, and you used to write a MapReduce job. The output of this MapReduce job was written back to your SDFS. Okay. Again, if you have another MapReduce job which would again consume this data, then you would again write a MapReduce job here, right? Which would again read the data of from this SDFS and again process it, again writes the data into SDFS. Okay. And your SDFS is basically a part of your disk. It's a part of your disk. It's not a part of your memory, right? And that is where your MapReduce used to be very, very slow. The reason is because every time you want to run your MapReduce program, the data has to be loaded from your SDFS to your memory, get it processed, and then again the output would be thrown back to the disk, that is SDFS, and the story continues. This made your MapReduce really slow, right? Whereas if you talk about Spark, in Spark what happens? The data initially may reside in your SDFS, okay, and then when you write your Spark job, this data would be loaded into your memory, which means RAM, right? And Spark would start processing the data in memory itself, and then the temporary output what you get, the intermediate output what you get out of this Spark job would still be on your memory. So the intermediate output of your Spark would be still in your memory, and again what you do, you write another Spark job. So if you see that one Spark job and another Spark job, right? So the way they are exchanging the data is actually sitting in your memory, that is your RAM, and that is what makes your Spark very, very good in performance, right? And that is the reason we say Spark is basically a distributed in-memory computing framework, right? So that's the biggest difference between a MapReduce and Spark. The question was, will it be replaced? Okay, now the answer would be no, it would not be replaced. I'll tell you the reason. See, most of the companies are still using MapReduce as well as Spark together. Okay, so if they have a requirement, if they have a use case where they want to process the data really fast, then they basically write the solution in Spark. Okay, and if they don't care about processing the data, it's okay to get the data in some delay, with some latency, then they basically go ahead and then work on MapReduce, right? For example, let's take an example. Suppose you have like a bank, right? And the bank wants to process all the transactions that was done by the customer in the last 5 years, right? Now if you look into this requirement, I don't need it immediately. It's okay if I get that output maybe in 1 hour, or maybe in 10 days, or maybe in a week, or maybe in 2 days, whatever, right? So I'm not in a hurry to get this result immediately. So in this case, you would definitely, would like to use a MapReduce. The reason is it is slow, it's okay, but it is cheap. Okay, so see, all good thing comes at a price, right? All good thing comes at a price. Spark, if you feel that this is the best solution, it also comes with a price. And what is the price? The price is you have to pay for the memories, right? Because the memories are not cheap. It's not it. For example, like, think about this. If you want to buy a hard disk in the market, if you go and say, I want to buy a 2 TB of hard disk, what you will get is, you'll get this 2 TB of hard disk maybe at around 4,000 rupees INR. Okay, more or less. Now you say, so let's say I want to get 12 GB of RAM. Okay, so this 12 GB of RAM you may get around 4,000 rupees INR, more or less, right? So what I'm trying to tell you here is, even if you have 4,000 rupees, if you see the same 4,000 rupees can buy only 12 GB of memory. Okay, whereas the same 4,000, by using the same 4,000 you can buy a hard disk of 2 terabytes, right? So what I'm trying to tell you is, in an organization where you are actually dealing with a huge volume of data, right? Suppose you have 200 terabytes of data to be processed. Suppose you have 200 terabytes of data to be processed, then and if the processing, like if you don't care about the timing, if you say I'm okay if the processing goes slow, then probably you would like to prefer processing on disk, not on memory, because your data is so huge, right? So likewise, based on the requirement, as I said, every company would have a Spark as well as the MapReduce, and it depends on the priority. What is your priority, right? So do you want to process the data really quick? Yes, then invest a lot of money on getting these Spark clusters, right? And if you say I don't want to invest a lot of money, because at the end of the day, all the business unit, they want to save money by one or other way, is not it? So if you say, hey, I don't care about processing a data immediately, and it's okay if I get the data after 24 hours, 48 hours, I'll go ahead with MapReduce. Okay, now a typical example, let's see. So every time, right, when you buy some items, you use your credit card. Okay, and if you see, at particular day on every month you get the invoice of your credit card bill, right? Now think about this, how many people might be having the credit card of the same bank that you have? Many people, is not it? And if you see, all the people are actually getting the statement on the same day, most likely, right? If I say 5th, then it's 5th. If I say 10th, then it is 10th, and so on. So what these people are doing, or these companies are doing, they're actually processing your data in a batch, right? So what they do, maybe 2 days before or 3 days before or 4 days before, they run a job, and that job would basically get all the data, right, of all the customers who have done the credit card transactions in the last 1 month, which was not billed, right? So they will bring all these things together, they will do their calculations and everything, right? And then put them properly in a PDF format, whatever, or store it in the database, whatever, and then dispatch it to the end user, right? Prepare the PDF and dispatch it to the end user. And that's how, as an end user, we basically get the report at the same day most of the time, right? And if you see this job, like to work on this data, you really don't need Spark, because you're okay to start the processing maybe 4 days ago, 5 days ago, and it may take a little time because it is processing the data in volume, right? And that's where you can say, okay, I want to use MapReduce because my requirement is not to get the output immediately. Okay, so MapReduce and Spark, they both are basically engines, the processing engine to process the data. I'll make it very simple. You want to cook a food, okay, and if you want to cook a food, then you have two things. Okay, let's say you have a gas and you have a microwave, right? So this gas may take some time to cook your food. The microwave would be much more faster, right? Now that is how the difference I can say. Like if you see, both of them are used, right? So at your house you have microwave as well as you have gas, right? And you use it based on what you want to do, is not it? Similarly, you should not say that the MapReduce is outdated or Spark is only used. No, that's perfectly wrong, perfectly invalid. Okay, in a company you use MapReduce as well as Spark as the situation demands. If you have a job which would be working on huge amount of data and you are not really excited about the processing time, go ahead and then start processing the data using MapReduce. Okay, but then one thing you need to understand here is, I did not ask you to write a MapReduce code, is it right? So I did not say that you have to use a MapReduce code to process that data. Not really. You can use Hive, which internally uses a MapReduce, right? Or you can use Hive with the Spark as well. But again, the point is, you will have to pay cost separately, and the cost would be very, very different if you are utilizing Spark cluster or if you're utilizing MapReduce. The setup, the infrastructure cost would be very, very huge. So company basically prefers using both of them as per the situation demands. Okay, let's move on. All right, guys. So now let's talk about this Apache Spark. Who created this? When? Right. So Apache Spark was created by 𝗕𝗀𝗆. Okay, and it was done. The project initially started at 2009. Okay, at UC Berkeley as a research project, and then later it was handed over to ASF, Apache Software Foundation, in 2012. Okay, and 𝗕𝗀𝗆 is also in LinkedIn. I would suggest you to check out his profile, and if possible send like a connection request to him, because it would be cool to get connected with the people who have actually invented the stuff, right? Okay, now let me do what, let me go back to my screen. We will like refer a document, and then we'll continue our discussion from the document. So that's how, what we do is all the concepts on the board, okay, and all the materials from the notes, and all the experiments, all the POCs, all the code execution on the board, on the screen itself. So I'll just share my screen now. Okay, so we'll always follow this document. You get this document in our LMS itself. Okay, under the notes section, I'll tell you that later. I would say you can just check the video link description. In the description, we have given the link. How can you get access to these notes? Okay, so that should be fine enough. All right. So as I said, the creator was 𝗕𝗀𝗆, date 2012, and he's currently working as a co-founder and CTO of Databricks. Okay, and in his study of PhD, he created the Apache Spark project and co-created a project called Apache Mesos with other folks, right? So if you want to get a lot of information about Apache Spark, you can refer to this homepage. And this time, these guys have created an awesome homepage. Like it looks like they've done a lot of work at the UI level, and it does not look so boring that it used to be earlier, right? But then if you see, you can use Python, you can use Scala, you can use Java, you can use R to work on Spark, right? And the main advantage of this Spark is people who are also data scientists are also using Spark. So it has become a must technology for either the data engineers or the data scientists as well, right? So people who are also doing data science work, they are also using Apache Spark. That's the good beauty of this framework altogether. Okay, now as I said, this is the LinkedIn profile. Just go ahead and then see. Try your luck. If you can be connected with him, he may share you a lot of updates, whatever they are doing, and it's really a good thing to get connected with people like them. Okay, now so 𝗕𝗀𝗆, and I have already shown you, he is the guy 𝗕𝗀𝗆. Okay, his name is 𝗕𝗀𝗆. Okay, let's move on. So the popular there are few popular frameworks which are used to solve the big data problems. Okay, so earlier when Spark was just started, right, people were so crazy about MapReduce. People were also crazy about other technologies like Tej and Storm. Okay, and if you see, the MapReduce is meant to process the data in a batch, and it's basically a batch processing framework. Okay, Tej to some extent can do a batch as well as interactive. Storm is for real-time streaming, and Spark can do everything together. So these days Spark is the market leader, and we use Spark almost in every kind of opportunities. As I said, unless and until the data is so big, or you don't really want to get into you don't want to really spend a lot of money getting a Spark cluster, then you would basically use MapReduce. So today people are either using MapReduce or Spark, or combination of both, whatever works. Okay, now when we talk about batch processing, what do we mean by this batch processing, right? So batch processing means what? Grouping the data together collectively and processing them of n number of days, right? For example, if suppose somebody asked me, get me the report of last 1 year. Let's say we work for 𝗵𝗵𝗃, let's say, right, which is taken over by Reliance now. So let's say we work for 𝗵𝗵𝗃, and the 𝗵𝗵𝗃 business team says, we want to find out what kind of products are giving us more profit. Okay, not sales. Sales and profit is two different things, right? So we would write our code, right, and then we may have to analyze maybe a last 6 months of data, or maybe last 1 year of data, right? Because you cannot just count the margin or anything by just looking at yesterday's data. You may have to look into a huge volume of data. So if you want to pick up some data of, let's say, last 1 year, then you would basically do them in a batch, and we call them a batch processing, which means the last 1 year of data, last 6 months of data, last 3 years of data, and so on. We call it a batch processing. Okay. Now, iterative. What do you mean by iterative? So when you are writing any sort of machine learning code, right? So you'll have to classify, let's say, an image, and the image could be anything, right? So for example, the image may look like a pineapple, but it may not be a pineapple. Okay. Or the image is looking like it's a dog, but it may not be a dog. It could be deer, probably, okay, with no horns, or no scratches on the no marks on the body, right? So if you look into any machine learning algorithms, mostly these machine learning algorithms are iterative, which means it will iterate forever, not forever, for a long number of time, and it will try to classify to what category it can actually come, right? For example, if I take a name, let's say any famous personality, he could be an actor, probably. He could be a sports person, probably. He could also be a politician, probably, right? And that is how basically you would classify. You can call him a sports person, a cricketer, or you may call him an actor, or maybe you may call him a politician, whatever, right? So likewise, whenever you are working on machine learning algorithms, there are situations where you would basically run your algorithm for more than one times, because you want to really identify what exactly it is, right? And that kind of processing are called as iterative processing. Okay, so that's what we have. Real time is something which is what people are crazy about, right? Everybody wants to do a real-time processing. And what does it mean? Real-time processing means we should process the data as soon as possible as it gets generated. For example, you go to your shopping mall, swipe with your card, right? And what will happen internally? The data would flow from the source, that is the store, to the database of bank, right? Saying that Suraj wants to purchase an item of 2000 rupees, right? And this is going in the real time. Now I should have a technology to identify if it is a fraud, probably. Okay, for example, I'll give an example. One day I was trying to book my ticket, a flight ticket, and I was trying to book my flight ticket, and it failed because of unknown reason. It failed because there was some issue with the airlines, probably. Okay, and I did transaction 2-3 times, but then immediately I received a call from SBI saying that we are calling from SBI credit card fraud team. We just wanted to check that there was a transaction initiated, from your end. Was that you, or was that somebody else, right? And trust me, they blocked my transaction because they suspected that it's a fraud. And I said, yes, it was mine, and they approved it, and it went smoothly, right? So likewise, there are so many places where you really need a real-time streaming, where the data should reach as soon as possible, right? In milliseconds, or maybe in couple of seconds, not hours. And when I say couple of seconds, let's say 30 seconds, 1 minute is also okay, as long as the transaction do not time out, right? But really it should be super fast, within a second or two, not more than that. Okay, even if you say I have designed a system which which can give you the output in 1 second, people would still call your application slow, because 1 second is something which human understands, right? Computer understands milliseconds. So you have to basically think about doing all these things in a millisecond approach, right? I was designing a solution where I was given a requirement to build something which can help a bank to search for any company, and the maximum time allowed for that search was 300 milliseconds. I had to build a solution which can actually give me the output in just 300 milliseconds, right? So when you talk about real time, it should not touch even a second, right? It should go somewhere in the milliseconds, of course, and it depends on the nature of the work, of course. Okay, earlier we used to work with Mahout for machine learning language. Okay, there used to be a framework called Mahout from Apache, again Apache Mahout. But then these days, machine learning, your Spark ML lib has taken a lot of credits, and a lot of people prefer using Spark ML libraries also, if they feel they want to run like the solutions on the scale. So Mahout was a MapReduce way of performing machine learning, and hence it was equally very, very slow. Okay, so let's move on. Use case. what are the use cases where people would be using this big data, Spark and all together, right? So let's understand this. Network fault analysis. Think about this. Amazon, right? Now, you cannot even imagine how much of network this Amazon guys have created, right? We always say cloud, right? So we always say, hey, it's a cloud. We are going to work on cloud. But let me tell you, it's cloud for you. But behind the scene, it's all Amazon who has actually, right, build the whole infrastructure for you. Is not it? And now if you cannot even think at what scale the infrastructures are created. Is not it? Now every infrastructure what you create will have a lot of machines. All these machines would basically, like talk to each other in a network, right? And they send some signals. We may have to analyze that, and we may have to identify if a particular machine is down, and that is what we call a network fault analysis. We may have a requirement to figure out if there is any problem with any of the devices within the network, and we call it a network fault analysis. You can easily do this using Spark, and it's not just about Spark, it's about processing the data, right? So as soon as you get the data, you should be able to process the data and get something out of it, saying that, hey, I see that there are 200 machines altogether in my network, but few machines have not responded in the last 1 minute or so on. So most likely these systems are down probably. Okay. Similarly, real-time advertising analysis. For example, you're watching YouTube video, you're traveling in Delhi. Okay, you'll see some ads. Now you go back to Odisha, you may see some other ads. You go to US, the same YouTube may show you some other ads, right? So this is how the real-time advertising would work eventually, right? So it will try to identify what is the location of the customer probably, or what is the search criteria of user. For example, see, everything is related. You search on Google, I want to buy shoes or a big data course, search it on Google. Go to YouTube. YouTube understands that, okay, this guy currently is, really looking for a big data course. So what it would fetch all the big data course marketing, which the company has given to the YouTube, right? And then it will start playing those ads because the customer is desperately looking for it. Similarly, you search for phone. I am looking for iPhone, and then when you go to YouTube, you'll see something very similar, right? So that's what we call a real-time advertising, where like the companies like Google and all, they are able to identify the customer's need in the real time and give you the details, because that's the way they make a lot of money, right? That's how the business works altogether. Next, predictive analysis, predicting something. Again, it's basically I would say a machine learning stuff, but then if you want to do it on scale, you will have to use a big data solution. Okay, predicting. So like, for example, can you predict the house rent of a particular house in a particular society? You can, right? The reason is because, see, you basically work on the sample data, you basically work on the previous data, the history data, right? And then based on that data, you can actually get some graph, and you can say, okay, looks like this particular house, which is 2 BHK, having this facility, should cost me 15,000 rupees per month on rental basis, right? And you basically get this information, you basically get this result by just looking into all the previous history data. That's what machine learning does. And if you want to do it on scale, then you would need a Spark. Is not it? That's what it is. Okay, credit card fraud detection. Sometimes what happens, your credit card may be transacted from 3-4 different places, okay, of the geography. And how is it even possible? Not even possible, right? So most likely these days, almost every credit card companies have already implemented this facility, that if they see a lot of transactions coming out from different geographical location, then they would try their best to stop the transaction as soon as possible. Most likely the first transaction may not be prevented, because you don't know what is happening, but then the second transaction may be prevented because the first transaction was made on Hyderabad, the second transaction is done on Mumbai or from some other location, so that could potentially be a fraud, right? Next, weather reporting, forecasting, right? So think about this. These days, it's very easy to identify when will it rain, right? Will it rain tomorrow? Most likely yes, or most likely no, right? So if you look into the weather forecasting today, you will know if it will rain in Hyderabad or not. Okay, but will you know will it rain in 𝗂𝗂𝗀𝗆 or not? Definitely not, right? Because these days generally the weather forecasting team, they basically give you the weather forecasting report of an area, the whole area. When I say Hyderabad, it's just the Hyderabad, right? But then it may not exactly tell you whether it will rain in 𝗕𝗏𝗏 or not, and if it would rain, then how much it would rain, right? Think about this. I host a company called I host an event management company, and my job is to take the order from the customers. And the customer says, "Hey, we have a wedding tomorrow at 𝗂𝗂𝗀𝗆. We want to make sure that you do all the necessary arrangement." Okay. Now let's say we did all the arrangement, and then we never estimated that it would rain tomorrow. Okay, and we have not taken any precaution of the rain. Then what would happen is, tomorrow if it rains, then the customer would abuse us like anything, right? Because at the end of the day, they are paying us money, right? And then if it rains, then it is your duty to bring everything together, right? So in these kind of use cases, you can definitely customize the weather forecasting for a particular area. Okay, you may get the data for Hyderabad, but then what if I want to get little information about a small place called 𝗂𝗂𝗀𝗆? Will it rain tomorrow there or not? And this kind of facility would definitely help a lot of event managers across the country, is not it? Because see, every day many people are getting married at different place. Every day there is a party at different place, every city, right? And this weather forecasting, customized weather forecasting would definitely help, right? And it's like, tomorrow will it be a hot summer? Like, will it be a hot weather? If yes, then how much in this particular place, right? So likewise, you can definitely do a lot of analysis, right, using Spark. Okay, next, healthcare analysis. Now when you go to a doctor and you say, I'm not feeling good, I have a problem, it looks like it's spinning here and there and whatnot, right? So the doctor would basically suggest you to do few tests, right? And when you do the test, what happens is, basically based on the test, the doctor are actually trying to identify your problem. And if you see, the doctor, they don't call themselves an expert, they always say, I'm practicing, right? I'm practicing in this hospital since 20 years. That's the statement the doctor says. The doctor never says that I'm an expert in this field. They say I'm practicing, right? The reason why they say is because every day one or other new parameters are discovered and they are still learning every day, right? So now, if given a sample, a blood sample of let's say 1 lakh people, and you found out some common pattern, like people who have this problem would definitely, they have a high chance of getting heart diseases, right? And if you look into the report, if you look into the past data, and if you can make some sense out of it, then it's basically so if you basically look into those information, right, those informations will be basically very handful and handy, and you can build some sort of model which can actually give you most likely a very accurate result based on the data of the patient, right? So whatever data we have already recorded of all the patients, we may use them to make our hospital to make our medical like healthcare system little more better, is not it? Because see, you don't get a lot of good doctors everywhere in every place, right? But what about building a system which already has a lot of data which you have already learned in the last 30 days? Think about this. Close your eyes for 1 minute. Think about how many hospitals are there in India. Google it out, right? And let me tell you, most of the hospitals are always busy. There are a lot of people who goes for the same problem. Everybody has diabetes, everybody has BP, everybody has these and that and all. Now, if we collect all the data of these customers, right, and then put that in the database, a centralized database where we can do some analysis, then it would be really great, right? So we can also use that in the healthcare analysis, of course. Okay, next, you can also use it on financial risk estimation, right? So for example, financial risk, I want to get a loan, I will go to a bank, right? The bank may give me a loan. The loan basically are of two types: secured and unsecured loan. Secured means I will submit something to get that money, right? For example, I have submitted my gold and I said, take my gold, and this gold is worth 3 lakh rupees probably. You test it, the gram, the weight, the purity, it's worth 3 lakh rupees. I need a money of 50,000 rupees. I'll give you interest on it. That's a secured loan, right? And the interest rate would be really very less in that case, okay? But then I may say, I have nothing, I just want a personal loan. I'm okay to pay 14% interest. I need money, right? So the bank would do some sort of validation, but they would not keep anything as a guarantee, right? And in that case, what happens? Many people actually default the loan. They don't pay. They just run away, right? So big data can also be used in identifying what is the risk in the financial institution if we give a loan to a particular people. How can we do that, right? So there are a lot of approach. See, I'll tell you, when I was working with a startup, I was working with a fintech company, which was actually trying to profile a customer based on their behavior, right? Based on their data, based on their mobile data. For example, by looking at your SMS, I can know if you gamble or not. By looking at your SMS, I can know if you have children or not. By looking at your SMS, I can know where are you traveling frequently, right? To which city you basically go if I look into your previous data. And that helps me to build a solid, discovery about you, that, okay, you belong to Odisha, and I've seen you moving from Hyderabad to Odisha many times, few times by flight, few times by train. Sometimes you also go to, like Mumbai, probably you have some friends, right? And so on. And maybe you are, putting some money on rummy, or maybe putting some money on gambling websites. So most likely, we will not give you a loan, probably, right? So I'm just giving an example. What could be the reason? What could be some of the reasons that can be used to help any organization to understand if there are any risks giving a loan to a particular customer or not. Okay, so there are a lot of use cases. These are only few that I could state, right? One more use case I would like to give you. When I was working with Apple, what we were trying to do was we were trying to build the map of the entire world, right? So when you open a Google map, you say, I want to go from A to Y place, right? So when you say A to Y or A to Z, right, we basically give you that path, right? Which road should you follow? It's not it. We were actually doing the same thing at Apple. So what we were doing was we were trying to build the system which can help our iPhone users, right, to move from one place to another place, right? And what was the reason we were trying to do that? Was Google not sufficient? We wanted to build our own, your own system, so that our users are sticking to Apple Maps only, right? So that's what it is. And then in that case, we would basically work with a lot of data from a lot of countries, right? And all this data would be brought from some sort of party called OSM, OpenStreetMap. You can also download them. They are a free map data available in the internet. Okay, so you may have to pay for getting better quality data, but if you want to try something, you can check it out, Google it out, OSM, OpenStreetMap. And what we were doing was we were analyzing this data and building a lot of getting a lot of information out of it, and collecting some information from here, collecting some information from there, ultimately creating a map, right? So that time also we were absolutely using Spark, right? And then our pipeline used to run for almost a week, or almost, I would say, if there is no manual intervention, then it would basically run for at least 48 hours. Okay, so it does not mean that Spark means millisecond and microsecond. Okay, it depends on what kind of data you are working on, and is that a real-time streaming. We were not doing a real-time streaming for that, for solving that particular use case. Okay, so we'll talk more about this as we move on with the program. Okay, now we have also let's talk about this limitation of MapReduce. We've already discussed that MapReduce always prefers reading the data from a disk, right? SDFS is where you store the data, and every MapReduce job would read the data from SDFS, processes, and sends the output back to your SDFS, right? And this process continues, and SDFS is always a disk. That is what makes your MapReduce really slow, right? And let me talk about a benchmarking which can help you to understand how can you basically decide if MapReduce and Spark would take same time, or how much fast is your Spark. Okay, so this is a benchmarking which somebody did, not me. Okay, I just collected it from some source, and what they said is there was a MapReduce job which was executed in one iteration, only one time. Okay, and it took 110 seconds where Spark took 80 seconds. Okay, so they wrote a MapReduce job, they wrote the equivalent Spark job as well, and that MapReduce job was supposed to run iteratively. Okay, and the first iteration took 110 seconds for MapReduce job, whereas the Spark took 80 seconds, which looks very similar, right? Does not make a lot of difference. 80 versus 110, that's just 30 seconds, and it does not make a lot of sense. Okay, now, but the same MapReduce job with 30 iteration, the same job was again iterated for 30 times. It took almost 3,500 seconds. Okay, whereas in Spark it just took 80 seconds plus 29 seconds, 1 second for each iteration. Here is the beauty now, right? So see, now we are coming back to 110 seconds. It took almost 110 seconds with 30 iteration, and this took 3,500 seconds. Now comes a huge gap, right? And why did this happen? Let's understand. In case of MapReduce, you are iterating, you are running the same job again and again. So what is happening? You're getting the output from SDFS, processing, writing the data to SDFS. Again, second iteration, reading the data from SDFS, processing, again writing the data to SDFS. So this reading and writing itself is taking a lot of time because you are actually writing the data in a disk. Whereas in Spark, it is really fast because you are reading the data directly from your memory. You have a memory and your memory is holding the data all together. Okay. All right. So Spark was coded in a Scala language, which is short and precise, and therefore entire source code has around 20,000 lines of code, whereas Hadoop 1 has 90,000 and Hadoop 2 has 220,000 lines of code. So it's not about the line of code. I just wanted to highlight it. Okay, but then it's really not about the line of code, but it's about how fast can you build a solution, right? So see, MapReduce and Spark, they almost do the same thing. The only difference is one does in a SDFS way, right? Reading the data from disk and all. The other one does it in memory. The MapReduce does it on disk, and your Spark does it in memory, right? Now, if you talk about the development, it took less time to build a Spark code because Scala is so short and precise. Okay, whereas your Hadoop is written in Java, and to be very honest, I have been working on Java since a long time. I started writing my first Java code in 2004 when I was in class 11, right? And then 2004 to 2020 is 16-17 years in Java, right? But then I have recently learned Scala 5 years ago, and I feel Scala is quite more comfortable because you don't have to write a lot of things and you can still get the same work done. Okay, so that's what the Scala is. Okay, now the biggest claim from Spark regarding speed is it is able to run programs up to 1000x speed than your MapReduce in memory, or 10x faster on disk. Spark could make this claim because it does the processing in memory of the worker node and prevents unnecessary IO operation with the disk. The other advantage Spark offers is the ability to change the task even at the application programming level without writing onto the disk at all or minimizing the number of writes to the disk. So when you start writing a Spark code, you will understand how easy it is to change the job. For example, I have a data. Okay, I want to do some processing. I'll get some temporary output. On that, I want to do one more processing. I'll get another output. On that, I want to do one more processing. So you can basically chain it up. Okay, you can just chain it up in a single line. That's the beauty of your Spark. In your MapReduce, what you should do? You should write a mapper code. You should write a reducer code. Let that program run. You get the output in the output file. Again, you will write another job. Again, that would read the data and so on. And ultimately, you can definitely chain it up also using 𝗎𝗎 or using some other technique. But then this would need you to write mapper code, reducer code, mapper code, reducer code for every small job. Okay, that makes it a little irritating when you are building something on MapReduce. Okay, so that's one thing. One more thing that you get benefit when you are using Apache Spark. Okay. What is so how is this Apache Spark super fast, right? As I said, the main reason is in memory. The second reason is you have a concept of advanced directed acyclic graph. And what does it mean? See, when you are writing a job in your Spark basically breaks down that job into a graph. Okay, so we were talking about this, right? So when you are writing a Spark job, you have a source. Okay, you may have source, and then you want to do something, right? So you will say, I want to do this step. Then I want to do this step. Then I want to do this step. Then I have one more data here. Okay, and I want to do a join. Likewise, okay. So when you write your instructions in a programming language, right? So when you do this on Scala, internally what will happen is a graph would be created, directed acyclic graph. Directed means with a direction, okay? So with a direction like this. This is step 2. Okay, so this was source. There's step 1. I did step 2. Then we have step 3. We did step 3. Okay, after that you have this source, right? This source and this step 3 output. This source, let me make it like this. This source, I'll bring it here. This source and this step 3 output is joined. Okay, and you get the final output. Right. So whenever you are writing any like program on Spark, you would basically write a lot of steps involved, whatever, and all these things would be internally represented by a graph. We call it directed acyclic graph. Directed means they will all have a direction, and acyclic means there would not be a loop. It would not be a for loop anytime. Okay, there could be internal loop here, but then there would not be loop in the graph itself. So this kind of advanced direct acyclic graph is used by Spark, which can help you to easily identify what are the steps involved here. Okay, and given a chance, you can actually cache this step. You may say, okay, I've done this by taking a lot of effort, and now let me store this data in a cache. Okay, so that I don't have to redo this step again, and that would make your Spark more super performing. Okay, and that's what we would be basically looking as we move on with the program, right? So that's how the whole Spark works. Spark has a concept of directed acyclic graph, which will represent every instructions in a graphical presentation, and whenever you feel you want to cache something, you can do that. And in few cases, your Spark will automatically do the caching for you. We will also talk about that as we move on with the program. So I've already answered this. Will Spark replace Hadoop? As I said, they are used together. Okay, and let me tell you, most of the time, see, Spark is just a processing framework. Okay, it can just process the data, but it does not have a storage. It cannot store the data. Spark is not meant to store the data. It's meant to only process the data. Okay, so now to store the data, either you have to use SDFS, or you have to use S3, or you have to use some other storage framework. It's not it. Now, most likely companies are using S3, Amazons and all, if you are working on cloud, and mostly you also use SDFS, because there are few companies who says, I cannot rely on the cloud. Let me be very honest that while we were trying to work with a couple of like clients, they were very, very clear that I don't want to use a cloud. I want all my data to be with me, no matter what, right? They have no other option than install all this data centers at their own premises and then run your Hadoop on top of it. So if that is the requirement, then forget about cloud. Okay, cloud will not even be approved. You will still have to rely on SDFS. Okay, so now it does not, like, see, it depends on with which customer you are actually working. You cannot go and convince them that why don't you use cloud. They don't want to use it. Simple. It's not it. For their own security, they don't want to use it. Okay, so if there is a requirement where the data, the company is already using Hadoop MapReduce earlier, they already have SDFS, and they may not be interested to go into the cloud, probably, right? If that is the case, then you would still be processing the data in SDFS. So see, as I said earlier, that you have two approach. You have MapReduce or you have Spark, right? And as I have told you that this MapReduce approach is, just a minute, let me go back. Okay, so you have two approach, MapReduce and Spark, to process the data. Okay, now typically in any organization, everybody wants to save cost. Simple, it's not it. So typically in any organization, you will find a lot of jobs which are actually running on MapReduce framework. Okay, and let's say they want to solve some of the use cases for which what they did is they have created their own Spark cluster. Okay, you may say, why would people create two different cluster, big data cluster, MapReduce cluster and Spark cluster? Why do you even need that? Can we not do it on a single go? Can we not do it on a single cluster? But let me be very honest, guys. When you are working with bigger companies, you will find tons of clusters. Cluster number 1, cluster number 2, cluster number 3, dev cluster, dev 1 cluster, this cluster, that cluster, and whatnot. There would be a lot of cluster. Organization would not rely only on a single cluster, right? So it is possible that few organizations may say, I'll have 5 dev cluster where all the programmers are allowed to bring the data, process whatever they want to do. I would have 3 testing cluster and I would have 7 production cluster. It is purely possible. Okay, so in a company you will not see only one cluster, you will have multiple cluster, of course, because what if one development cluster is down for some reason, right? Company cannot give holiday to all the developers. If they do, then who is going to develop the solution? Is not it. So there is always a backup: development cluster, testing cluster, production cluster. So it is possible that like couple of production clusters are MapReduce cluster possible, and couple are a Spark cluster. Okay, and this Spark cluster would cost them a lot. As I said, compare the price of 4 terabytes of hard disk and maybe 12 to 16 GB of RAM. The price is same, right? Which means if you use 16 GB of memory, then you can use only 16 GB of, you can store only 16 GB of data. Is not it. But if you create a SDFS out of your 4 TB, then you can store 4 terabytes of data, whatever, right? So that's how the cost would come down, right? So as I said, your MapReduce and Spark, they are used together, right? Sometime based on the requirement, the company may say, hey, we don't need to execute this job as soon as possible. It's okay to wait. Let us schedule it on MapReduce job because this is not a super high priority job. And if you feel there are some super high priority job, then you should use Spark. Okay. And as I said, I wanted you to be very, very clear. Spark cluster, Spark job does not mean that you'll get the output in 1 second. No. If you feel that, then you are wrong, completely wrong, right? So Spark can help you to process the data faster, of course, but then it takes time. For example, when we were processing the data, I'll give you one use case where we were actually processing 2 terabytes of data, okay, and we had almost 300 node cluster, okay, and this usually used to take 48 hours to complete the job. The reason is because we were doing a lot of things. We were doing a lot of things on this data. And when I said 300 node cluster, that's the size of the cluster. That does not mean that I have used all the 300 nodes, right? Like based on the requirement, like few nodes would be free, few nodes would not be free, and that's how actually it happens. In the real time, you will see a lot of people running the job parallelly, right? Your job is also running, others' job is also running. Sometimes we come into a situation where the job is really slow and we have to talk to the admins saying that, hey, the job is slow, and they look into the job, they see which job is taking a lot of time. They inform the author that, hey, your job is taking a lot of time. Is that expected? If no, then let us kill it. And they kill it up and then the server gets free. Okay, so that kind of situation also comes in the real time, is not it? So as I said, you will be basically processing a lot of data and it takes time. And it does not mean that we have got a new Spark cluster. That does not mean that you will get the data in milliseconds or microseconds. Okay, but yes, if you want to do some sort of real-time streaming, then it's a different story. In the real-time streaming, what happens is you basically send the data every milliseconds, right? Every milliseconds you send the data, and hence the processing is really, really fast. But you can use your Spark to process the same batch data. The only difference is it loads all the data into the memory and then processes it. And of course, that would be much more faster than what you would have done in your disk. But again, Spark comes with a cost, right? So if you want to bear that cost, you'll get the speed. And if you don't really want to spend a lot of time and money, if you don't want to spend a lot of money and resources, on getting that job done, better stick on your MapReduce. Okay, so as I said, if the company is not ready to get into the cloud, and if they already have their Hadoop cluster up and running, most likely they will use SDFS. Okay, and SDFS is given by Hadoop, and MapReduce is just a framework. So you can always say, yes, I can replace the MapReduce with a Spark job, but SDFS would remain intact. So SDFS is a part of Hadoop. That means Hadoop is not going anywhere right now. Okay, till today it has survived. I have started using this Hadoop in 2012. Okay, it's been almost 9 years. Right, that time, if you see, that time Spark was just getting introduced in the market, right? So that is how it was. So then onwards, like slowly MapReduce job started fading away. People stopped writing MapReduce jobs slowly over the period of time, and people started learning this Spark framework, and then onwards there's no look back, right? Spark is doing really great since last 5 years. Okay, and this has been one of the like top trending technology in the field of big data, and the good advantage is it is also used in the data science field. So you should not worry about making a career in Spark, because Spark has a really promising career, of course. So today we'll stop here, guys, and as I said, when we release this video in our YouTube channel, look into the description of the video, wherein there would be a link of how can you get access to our 40 hours of free program. I want everybody to utilize this, because 40 hours is a lot of learning, and I can promise you that after completing this 40 hours of program, you can pick up any book, take it forward, you should be able to understand almost everything, because the fundamentals are made very, very clear. Okay, so we'll continue again in our next class.